What if everything you thought you knew about the universe's beginning was just the tip of the iceberg? Imagine this, the vast cosmos, with its swirling galaxies and infinite mysteries, all born from a single, explosive moment, the Big Bang. But here's the twist: what if that moment wasn't the true beginning? What if there's a deeper story, hidden in the fabric of time itself, waiting to be uncovered? We've all stared at the night sky, overwhelmed by its immensity, wondering where it all came from. It's a question that tugs at the core of our existence. Yet, the answers we've been told might only scratch the surface. Could the universe have existed before the Big Bang? Are we part of an eternal cycle, or is there something beyond even that? These are not just questions for scientists, they're questions for anyone who's ever dared to wonder about their place in the grand cosmic tapestry. In this journey, we'll dive into the mysteries of the universe's origin, challenge conventional theories, and explore mind-bending alternatives. Together, we'll unravel the clues left behind by the cosmos itself. And who knows? By the end, you might just see the universe, and your place in it, in an entirely new light. Picture this: before there were stars, galaxies, or even time itself, the universe was a riddle wrapped in absolute silence. No light, no space, just a mysterious singularity where the rules of physics as we know them ceased to exist. It's baffling, isn't it? Imagine a computer without power. Its potential is there, but nothing is functioning. That's how scientists describe the universe before the Big Bang: infinite energy and possibility, but entirely dormant. And here's the twist: without time, how could anything happen? That's the kind of question that keeps physicists awake at night. Some propose the universe existed as a quantum void, a realm where particles flickered in and out of existence. Picture an utterly dark room where, for a fraction of a second, a spark flares and vanishes. It's fleeting, yet enough to suggest something remarkable could ignite. Then came the Big Bang, a cosmic explosion that shattered the stillness and set everything into motion. It's like flipping on a light switch in a pitch-black room. Suddenly, everything is illuminated, and the show begins. But what exactly emerged from that first burst of energy? That's where the story of particles and atoms takes center stage, and it's a tale worth unraveling. In the wake of the Big Bang, the universe was a chaotic sea of energy, blazing hotter than a million suns. In those first few moments, the intense heat forged the building blocks of everything, tiny particles like quarks and electrons. These particles swirled in a cosmic dance, too hot and energetic to form anything stable. Imagine trying to sculpt something out of steam. It's there, but impossible to shape. That's how the universe behaved, restless and unruly. As the universe expanded, it began to cool, and the particles started to settle down. Quarks teamed up to form protons and neutrons, creating the core ingredients of atoms. These building blocks eventually bonded with electrons, forming the first atoms, mostly hydrogen and a little helium. Think of it like baking bread: individual ingredients mixed and heated to perfection, creating something new and fundamental. By the time the universe was just a few 100,000 years old, it had transformed from a chaotic furnace to a calmer, dimly lit space filled with these newborn atoms. This marked the beginning of structure in the cosmos, paving the way for stars, galaxies, and everything else. But how do we know this story? The clues lie in an extraordinary relic still visible today: the cosmic microwave background radiation. Even today, the universe whispers secrets about its origins. One of the most compelling pieces of evidence is the cosmic microwave background, CMB, a faint glow of radiation that fills the entire cosmos. Discovered by accident in the 1960s, it's often likened to an afterglow from the Big Bang itself. Imagine the hiss of static on an old radio. It's subtle, but it carries a message from billions of years ago. That's the CMB, a silent witness to the universe's fiery birth. The CMB isn't just a random glow, it's a treasure trove of information. Its patterns and tiny temperature variations reveal the state of the universe when it was just 380,000 years old. At that moment, light could finally travel freely as the first atoms formed, ending an era of cosmic opacity. It's like peeling back the layers of an ancient artifact. Each detail tells a story about how the universe evolved from chaos to order. Scientists have used the CMB to confirm critical theories about the universe's early expansion, giving us a map of its youthful days. This radiation isn't just a relic, it's a guide, helping us piece together the puzzle of our cosmic past. But the story doesn't end there. How did this initial burst of energy shape the universe's vast, ever-expanding structure? Let's dive into the concept of cosmic inflation. The universe, as vast as it is today, was once unimaginably small, a fraction of the size of an atom. Then came inflation, a mind-bogglingly rapid expansion that occurred within the tiniest sliver of a second after the Big Bang. Picture blowing up a balloon, but instead of gradual inflation, it suddenly swells to the size of a room in an instant. That's how the universe went from minuscule to cosmic in the blink of an eye. This phase of inflation set the stage for everything that followed. It stretched space so quickly that even tiny quantum fluctuations, imperfections at the smallest scale, were blown up to cosmic proportions. These fluctuations became the seeds for the galaxies, stars, and planets we see today. Imagine scattering grains of sand across a vast desert. Those grains might seem insignificant, but given time, they shape the landscape itself. What's even more fascinating is that this expansion hasn't stopped. The universe continues to grow, with galaxies moving further apart like dots on the surface of an inflating balloon. But why does the universe keep expanding, and what's driving this relentless growth? To answer that, we must consider alternative theories that challenge the Big Bang itself, ideas like the cyclic universe and the intriguing concept of the Big Bounce. The Big Bang is the most widely accepted explanation for the universe's beginning, but it's not the only idea out there. Some scientists propose alternative theories, such as the cyclic universe, a model suggesting that the cosmos undergoes endless cycles of expansion and contraction. Imagine a cosmic heartbeat, where the universe pulses between big bangs and big crunches. It's a fascinating concept that raises a provocative question: what if this isn't the first universe, but one of countless before it? Then there's the Big Bounce, a theory that reimagines the singularity as a point of transition rather than an absolute beginning. Instead of starting from nothing, the Big Bounce suggests the universe could collapse to a dense state and rebound into expansion. Think of a trampoline. As you press down, the fabric stretches to its limit, only to propel you upward again. It's an elegant idea, offering a way to sidestep the enigma of what came before. These theories challenge our understanding of time and space, suggesting the universe may be far more complex and enduring than we imagine. Yet, they don't dismiss the Big Bang entirely. They seek to expand upon it, filling gaps in our cosmic story. Could the universe truly be infinite, with no true beginning or end? Perhaps, but one thing is certain: the quest to understand our origins is far from over, and new discoveries are always on the horizon. And there you have it, a glimpse into the profound mysteries of the universe's origin. But this isn't just knowledge to store away, it's an invitation to think deeper about our place in this vast cosmos. What does it mean for us, knowing that we're made of the same particles that once burst forth from the Big Bang? Or that the universe might be part of an endless cycle? Here's a challenge: take a moment tonight to gaze up at the stars. Let the enormity of it all sink in. Maybe even share your thoughts. What theory speaks to you the most? The Big Bang? The cyclic universe? The Big Bounce? I'd love to hear your ideas in the comments. Your perspective could inspire others to explore these questions too. Before you go, make sure to hit that subscribe button and turn on notifications. This journey through the universe is just getting started, and there's so much more to uncover. Let's keep exploring the cosmos together. You won't want to miss what's coming next.